the quiz yesterday.
Okay. Okay, so last class we started off with the section 3.1. So we have one more class period today that we're going to look at that, and then we will quiz on this so we can move on to logarithms next class. Now, I will also add, I'm sure you guys have not forgotten that there is no school Monday, which means I'll not see you again until Wednesday. So you guys know I always suggest to you to put alarm in your phone, put something in your calendar, do something to remind yourself about quizzes and tests. But especially with the long weekend, I feel like that's a little bit more relevant than normal. Also, if you're interested in the ACTM, I know I've been mentioning that for a while, but today's really the last day. So if you're interested in doing that, I need your $5 before you guys leave. So we are going to go over number 84, which is 3.1 extra practice. Then I'm going to ask you to go back and finish those two questions that we skipped last time. I didn't show you how to do them last time, but I'm going to show you how to do them within the extra practice. And then I went ahead and gave you guys the test review early, so that's got a bunch of stuff on there that you don't need to know how to do yet. But questions 1, 2, and 3, which make up the front page, are questions from 3.1. So I'm assigning them to you now because it'll kind of serve two purposes. One, it'll let you get a touch more practice in before the quiz, and then you'll have one page of the test review done, which will save you some time in the future, of course. Okay, so the first part of the extra practice. So most years we put some questions like this on our quiz and ask you to tell us which of these you think are exponential growth, exponential decay, or neither. For exponential growth, you're welcome to just abbreviate EG, and exponential decay ED. But I would like you to try all 8 of these because I think it will help highlight for you what mistakes you may make. So, no calculator, just glance at them. Do you think it would be exponential growth or exponential decay? And then we will kind of fill in the gaps. I will tell you that doing this with my 0 hour yesterday, there was not one person who got all 8 of them on their own. So this is why we're going over it a bit. But just do the best you can. So there's a couple of them that I think are a little bit easier. So I'm going to kind of start with those and then work my way out. But generally what makes something exponential growth, if you think of this as like a to the x, when a is bigger than 1, you can think of it as exponential growth. So question 3, 7 to the x is definitely exponential growth. But also number 6, multiplying it by 2 doesn't change the fact, I mean, it makes it go up twice as quick, but it's still growing exponentially because it's 7 to the x. Also number 7, because multiplying by a third is going to slow it down, but the 8 to the x makes it still grow exponentially. So I think those are the easiest of the exponential growths to get. Exponential decay, that's like when a is less than 1 but not negative, because if it's negative, that's actually has to do with whether it's being reflected or not. So the easiest of those would be like question 1, 1/6 to the x power would be exponential decay. And then that might be the only easy one. Of the easiest, or when I say easiest, I just mean most, I think, would have the least amount of mistakes. Neither would be that it's not an exponential function. So remember, exponential functions are when the variable's in the exponent. So in question 5, there is no variable in the exponent. In question 8, there's no variable in the exponent. Now, this being said, I saved 2 and 4 for the end because I think these are the hardest ones. They require that you remember an exponent rule. So we talked about this exponent rule last time, but it's just not one that you guys use very much. To use this greater than 1, between 0 and 1 rule, it has to be set up in this form. This has to be a positive exponent. If it's a negative exponent, you can't just simplify it to say, well, that's less than 1, so it must be exponential decay. This is not exponential decay. You need to change this from a negative x exponent to a positive x exponent, and the way you do that is by doing the reciprocal of what it's being raised to. So this is actually like 5 to the x, which makes it exponential growth. And then if we rewrite this one, This is like 1/8 to the x, which makes it exponential decay. So if you missed questions 2 or 4 or any of the others, then you need to jot something down there so you remember what it was that you didn't consider or what mistake that you made, because I've not seen our quiz this year. I'm not in charge of putting this one together, but we usually have a few of these on our quizzes, and in the past it used to be one of the most missed ones, and these are not hard points to get. So okay, anything y'all want to ask about that before I move on? Okay, then the only other, well, I don't know if I'd say that's new, but maybe new to us. The only new thing I need to teach you guys today is like questions 9 through 12. These are like the questions that we skipped on worksheet 1 and 2 together last class. Remember, we skipped this one. I didn't show you how to do this one, and I told you on the back that was the one that you could skip, but you should have tried worksheet 2 otherwise. Well, I'm about to ask you to do those because I'm going to show you how to do them. Okay, so for these question types, my suggestion to you, once you see how to do them, if you think of something better, then great, go for it. But what seems to help the students the most is there is at least one of these 3 things that I would suggest you memorize. If some questions may even use them more than once. But a lot of these questions will have some number and his exponent is headed towards 0. So if you have any number and the exponent gets closer and closer to 0, what do you think this whole thing is getting closer to? 1, because anything to the 0 power is 1. What about if you had a number and the exponent just keeps getting bigger? What do you think is going to happen to that whole thing? What'd you say? Right, it's just going to keep getting bigger too. You put in some number, you keep making the exponent bigger and bigger and bigger, the whole thing gets bigger and bigger and bigger. And then this one, any guesses on this one? This one's a little harder to see. Okay, so let's write it out like this. Remember, a negative exponent in the numerator is the same thing as a positive exponent in the denominator. And then from rule 2, if you have a number whose exponent keeps getting bigger, then that whole thing would keep getting bigger. And then I'm going to go ahead and show you this on a calculator because sometimes people have trouble seeing this. But if your numerator is stuck, it's still, but your denominator keeps getting bigger, then this fraction gets closer and closer to 0. Now, it's good if you understand why this equals 0, but since this is going to come up so much, this is one of the 3 things I would memorize. But just to try to help you see that, 1/2 versus 1/3 versus 1/9 versus 1. You don't even have to get a very big denominator before your calculator is running out of decimal spaces. This would be 6 decimals to the left. So 0, 0, 0, 0, 0, 5 zeros, and then this stuff. It's almost 0 already. Okay, so I would say you need to know these first. Memorize those 3. Every one of these questions will use at least one of these, if not more of these. Then, so what this is asking you is what y value is this approaching as x gets really small or really big? So just work them out separately. So the first time, just plug in negative infinity where there's an x. And then we have to step this off in as smallest pieces as we can because we want to figure out what's happening with this whole thing without a calculator. So if I look at this, this is one of those 3 things I just said that would be helpful to memorize. If you have a number and the exponent just keeps going to negative infinity, that whole thing goes to 0, which means my whole fraction, or my whole denominator is headed towards 2, which means my whole fraction is heading towards 7/2. So again, if you have that memorized and you don't have to think about why that's 0 and you can just make that substitution, it's not going to be difficult there. Okay, and then do the same thing with positive infinity. So plug it in. Try to do one tiny piece of this. So a number whose exponent keeps getting bigger just keeps getting bigger. And then if you add 2 to a number that keeps growing, that's just going to keep going to infinity too. Adding 2 as you get really big numbers basically does nothing. And then for the same idea as this, if your numerator is stuck at a number, but your denominator keeps getting bigger, your fraction is heading towards 0. So I'd like to graph this for you so you can see what it is we're trying to describe here. Okay. So here is the function that they asked us to work with, and again, we're doing these without a calculator, but the first time we did as x approaches negative infinity. So as the x values get really small, I said that the y values get closer to 3.5. So if I just go ahead and graph that at the same time, or I'll call it 7/2, but same thing. Notice the far left, my graph is getting very close to 7/2, even when x is as small as like -7, -8, -9. So it certainly approaches that as x approaches negative infinity. But then over here, I said it approaches 0. And I think you can visualize that, but I'll go ahead and have it graph it as well. As x gets really big, that original function gets really close to 0. So that's what we're trying to figure out. What y value does it approach on the left, and what y value does it approach on the right? So plugging in negative infinity and positive infinity, and then walking ourselves through the steps, we can figure out those numbers. But it certainly helps if you know these so that you're not having to juggle as much in your head. Okay, let me show you one more, and then I'd like you to try the third one before we go over it. So on question 10, I'm going to do negative infinity first. So you've just got to plug it in, and then you've got to step yourself through this as slow as you can. So like I'm going to look at just this for one step, just this exponent. Well, I have a positive 2 divided by a negative infinity. A positive divided by a negative is negative. And then 2 divided by a number that goes to infinity goes to 0. Whether it's 1/infinity, 7/infinity, or now 2/infinity, it's going to go to 0. But 0 is the only number that doesn't care if he's positive or negative. -0 is the same thing as +0. So now, from the first rule I asked you to memorize, this goes to 1, which means my denominator goes to 2, which means my fraction goes to -5/2. So again, the hardest part of that is right here. So let me say that one more time. I thought about the signs. Positive divided by negative to know that this was negative. 2 divided by infinity would go to 0, but -0 is the same thing as +0. And then I knew e to the 0 was 1 because of this. If you have a number whose exponent is headed towards 0, the whole thing heads towards 1. Okay, and then if I do that again with positive infinity, so I'm going to think about this first. 1/infinity would go to 0. Then this matches up with number 1. Anything to the 0 power is headed towards 1, which means my denominator is headed towards 2, which means the whole fraction is headed towards -5/2. Now, again, you don't need to graph this in your calculator because I don't want you to think that that's a way to get the answer anyway. But what I'm saying with this graph is, even though I have no idea what this guy looks like, I know the y values on the far left and far right of the graph both approach negative 2.5. The other thing is, notice for these last two questions, sometimes they can approach the same number, like we saw in number 10, but they can approach different numbers. So it just depends on the question. They might be the same, they may not be the same. You shouldn't assume that it should be one way or the other. All right, so go ahead and give it your best shot on 11 and see what you come up with. And we'll go over it, correct your mistakes, and then give you one more shot that we'll go over on the board together on 12. Okay, I think I'm doing this in my head, so I think this one might go to 0. Anybody else get 0 on that one? Okay, I'm seeing some yeses there. I'm thinking this one goes to -2. Anybody get -2? Okay, so if you got those two, it sounds like you're in good shape. You can go ahead and move on to question 12. But if you missed one or both of those, please follow along with me so we can try to help you highlight what you should have done differently. Okay, so plug in negative infinity. You should have a step that looks like that. Now, if you're trying not to write down the steps and you're going too quickly and you're making mistakes, then that's what's got to change. You've got to do that differently. Try not to do too much at once. So specifically, I'm just going to look at this exponent. A negative times a negative would be positive, and 5 times a number that keeps getting bigger is just going to keep getting bigger. Okay, and then this matches up the second thing that I suggested you memorize because it shows up so much. A number whose exponent keeps getting bigger is just going to keep getting bigger. If you subtract 3 from a number that keeps getting bigger, it's still going to keep getting bigger. And in a fraction, if your numerator stuck still but your denominator keeps getting bigger, the whole thing goes to 0. So 0 is correct. Try to make as many steps out of it as you can. More steps is better because you're trying to do less in your head at once. Okay, and if you missed the second part, check to see that you plugged in infinity. Right here, think about positive times a negative is negative. 5 times infinity would be infinity. And then this is not the same thing as this one. Again, sometimes they're the same, sometimes they're different. But e to the negative infinity is 0. That's the third thing that I suggest that you memorize. Makes it easier. So then your denominator goes to -3, which means your fraction's going to -2. So -2 was correct. Okay, let me give you a couple more minutes to try the last one, and I know some of you guys have already done it, so I'm going to go ahead and share the answer. So if you've gotten it right, you can go and start on finishing up those 2 questions we skipped last class that were about this. I think this is 0 and wait, no, it's not. I think this is 1 and 1. If you don't get 1 and 1, then don't move on from this yet. But I'll give you a few minutes to see if you can come up with that. There is a small chance I'm wrong there too, because I am trying to do it in my head. Okay. If you did not get 1 for the first part, then let's see where you went different. Okay, so I just tried to handle this part first, and I said a negative divided by a negative is positive, and 4 divided by a number that goes to infinity would go to 0. And then any number, whether it's e or likewise, if its exponent heads to 0, then that heads to 1. So your denominator heads to 4, and your fraction heads to 1. Okay, plugging in infinity. Try to just do this first. So negative divided by a positive would be negative, and 4 divided by infinity would head to 0. And then again, 0 is the only numbers that's the same whether he's positive or negative. So as soon as I realized that that is e to the 0, now it's exactly the same as above. So both of them do head to 1. So it just depends on the function whether they head to the same number or not. Sometimes they do, sometimes they don't. We saw 2 that did and 2 that do not. If I remember right, I think on worksheet 1 they either both head to the same number or to 2 different ones, but then vice versa for worksheet 2. Okay, so now that you have an idea of how that works, if you have a better approach to it, you're welcome to take it. But again, every one of these questions uses at least one of these 3. So if I was you, I'd make sure you had those memorized and ready to apply. Anything y'all want to ask about that before I slide this out of the way? Okay, then next up, what I'd like you to do is go back and finish number 83. That was the worksheet 1 that I did the front of for you, and worksheet 2, which was the back, which was your classwork / homework. We skipped 1 question on the front, and so then you skipped 1 question on the back. Bless you. But it's the question types that we just talked about, so you can now finish them. You do need to finish them to not get partial credit on that assignment. I know I said you didn't have to do them last time, just because I didn't teach you how to do it last time. Now I've shown you how to do it, so now you need to go back and do those. Then if you would do the front page of your test review, which is just questions 1 through 3, those would be all good question types for your 3.1 quiz. And that's the only extra practice you guys need to get in. But if I was you, I would take a moment, either in class or as homework, scan through the notes we did, make sure you're okay with that stuff. Scan over worksheet 1 and 2, handout 83 to make sure you're okay with that stuff, and probably look back at 84 again, the one we just did. That's what I would use to prepare for your 3.1 quiz. So, pretty short lesson, but again, not necessarily easy. A lot of it just depends on how much of this you remember from last year. I know, like the last question we just did, you probably didn't do, but most of this you should have seen. So, all right, and you also have about 50 minutes. So please go ahead and get that done. I do have 2 of these I'm asking you to turn in. So if you're the type of person that likes to turn it in early on Google Classroom, then feel free to. Otherwise, I will ask for it Wednesday right before we start the quiz.